All right, guys, we're going to continue our notes with Roman numeral 2, rational equations. And so there's a couple of different methods that you could use to solve rational equations. And what that just means is that you have an equation that involves a fraction. And so with that being said, let's take a look at A, and it's telling us to solve the equation for x. So method number one that we're going to try is to eliminate the fractions altogether. So the process of eliminating the fractions would simply be to find out what the common denominator would be out of all of your fractions. And so we can see that the LCD is going to be 6. All right, so if I were to add these fractions, my common denominator would be 6. So what you're going to do is you're going to multiply everything by 6. Okay, and then you distribute that, and you're going to be careful because the whole idea is to eliminate the fractions. So when you're looking at x plus 1 and then minus x minus 1, put those in parentheses so that you can keep track. But when you're multiplying that first term by 6, the 3 is going to cancel, and then you're going to be left with a 2. So essentially what you have is 2 times x plus 1. And then you, again, are going to be multiplying this guy by 6. And so the 2 and the 6 are going to reduce, which is exactly why you do this. So it becomes a 3. And remember that this is a minus sign. So you got to carry over that minus sign. And we're going to put the 3 on the outside, and it's 3 and then x minus 1. All right, so now we've eliminated those fractions, and we can say, all right, well, this is going to equal, when we multiply the 6 to the negative 2, that's going to give me negative 12. So with that being said, now we have something that we're more familiar with in terms of like a linear equation and one variable. So let's just go ahead and solve for x. So if I were to distribute, then I've got 2x plus 2. Remember, though, that you are distributing the negative 3 to everybody inside that parentheses here. So we've got negative 3x and a plus 3, and it equals negative 12. So the next step for us would be to combine like terms. So I really have a negative 1x, got a positive 2 and a positive 3. That gives me a positive 5, and it equals negative 12. From here, I'm going to subtract 5, and I've got negative 1x is equal to negative 17. Therefore, x is equal to positive 17. Okay, so that was one technique. This is method 1. And so when you eliminate fractions, the first thing you do is find the LCD of denominators. Then multiply each term to cancel. Okay, all right, and then the rest is you just solve. Right, then solve. Okay, so now let's look at method 2, which says to set up proportions. So with that being said, what we're going to do here is when I say set up proportions, we get the left side to be one fraction. So we would need our common denominators, which we've already figured out was going to be a 6. So you're rewriting each fraction with that common denominator. So I'm going to have to multiply this guy by 2. So I have 2 and then x plus 1 minus, and then I multiply this by 3, right? So minus 3 times x minus 1. And so I've got to combine those fractions here. So I've got 2x plus 2 minus 3x plus 3 equals negative 2. Now we got to clean this up, right? We got to clean up that first fraction here. So we've got 2x and negative 3x, that's going to be negative 1x. And then we've got positive 2, positive 3, that gives me positive 5. All over 6 is equal to negative 2. And if you wanted to, you could put it over 1 because that's how we're going to be setting up as proportions. But even if you wanted to not set it up as proportions and you just wanted to have something a little bit easier, you recognize here, or should, that you could multiply both this side by 6 to cancel that out and multiply this side by 6. And so you have negative 1x plus 5 is equal to negative 12. And then from here, you're going to subtract 5. Negative 1x is equal to negative 17. Therefore, x is equal to positive 17. Okay, and so that's where we're at with that method number 2. And I'm assuming, though, at this point, you already know how to set up proportions. So, for example, let's say that this was a 3. You would multiply the top by 3, and then you would multiply this by 6. So again, that's just going to be rewrite as, a over b is equal to c over d. So you're going to rewrite as fractions, simplified fractions here. All right. All right. So now let's take a look. I'm going to go ahead and delete this, make some space for myself here. All right. And let's say that we are supposed to state all the x values that are excluded from the solution set of the rational equation, then solve the equation for x. Oh, well, this is perfect opportunity for us right now, because in order for you to find the excluded values, you have to have your denominator in factored form. So you are looking in your denominator, you've set your denominator equal to 0. Or rather, not equal to 0, because you can't divide by 0. So let's take a look at the first one. X minus 1 should not equal 0. Now let's go ahead and solve. We've got x cannot equal 1. So that's the first one. Now we're going to take a look at x plus 2. So we've got x plus 2 cannot equal 0. So we're going to subtract 2 to each side, and we say that x cannot equal negative 2. Now let's take a look at that one. We've got multiple factors here, so we just set each factor not equal to 0, essentially, so that's 1. And then we've got x plus 2 not equal to 0. And so you have not equal to 1, and then you also have not equal to negative 2, which is something that we've already had. We already had that here and here. So the only exclusions we have is that x cannot equal, and now I want you to list them in order from least to greatest. X cannot equal negative 2, and it cannot equal a 1. So those are our restrictions. All right, so now that we have our restrictions, we can go method 1 or method 2. I personally find it easier to multiply by the LCD, so that way you can get rid of the fractions, but personally it's really just a personal choice. So my LCD would be every denominator has to be represented. So if you notice, I'm going to start with the left. I notice that I have to have a denominator of x minus 1. I also have to have a denominator of x plus 2. So I look over here, I already have x minus 1 and I already have an x plus 2. So that's all I need. So that's my LCD. So what I'm going to do is multiply the x minus 1, the x plus 2, times 1 over x minus 1. And I like to put my binomials in parentheses. And that's going to equal, right? So now we've got 2. I'm going to leave some space over x plus 2 plus, and then 7 over x minus 1, x plus 2. So what I'm going to do is change colors here. So what I'm going to do right now is when I multiply this term, because you're going to multiply both sides by the LCD, so x minus 1, x plus 2. So the x minus 1s will cancel, and then I have x plus 2 times 1, which is just x plus 2. And then I've got x minus 1 and then x plus 2 times this guy, which means the x plus 2. So if I wanted to so I've got x minus 1 times x plus 2 times this guy. So x plus 2 cancels. I've got 2 times x minus 1 for the first fraction plus, and then the x minus 1 and x plus 2, well, they actually just cancel those, so I just have 7. And now look, I have something a lot easier for me to deal with. I've got x plus 2 is equal to 2x minus 2 plus 7. I've got x plus 2 is equal to 2x plus 5. Then I'm going to go ahead, I'm going to subtract x on this side, so I'm left with a positive 1x. And then I'm going to subtract 5, and it looks like 1x is equal to 3. And so from that point, what you should do is really plug in and check to make sure that you're right. But for purposes of this video, I just wanted to go over that set with you.